And welcome back. I'm joined again by Sandro, Mash and Steve. Last time we were talking about the technical strategies for making your software easier to change. In the last episode, we kept the conversation at an enterprise architecture level with some strategic ideas and approaches for your strategy. In this episode, we're going to take it down to the lower level of detail. And we're going to give you some practical examples of tried and tested techniques with some specific examples as well about how to make your software easier to change. So with that in mind, I'm going to open the conversation up.
So I think that there are many different types of software modernization techniques that we can use. And there are also many different architectural styles or even patterns that we can also apply. But they will vary depending on the focus that we give to the modernization effort. And although in the previous episode, we talked more at the high level in the very business strategic view, when you get closer to the actual systems, we also need to focus in that. We need to be very clear of what we are trying to improve. And depending on what we are trying to improve, we might use a slightly different architectural pattern or technique. I can give you a few examples just for us to get started. A common one is that eternal, how can I say, dichotomy. Oh, we need to build new features, we need to do business as usual, but we also need to modernize. So how can we deal with that? So in that approach, let's say that we create a technical vision, but we can use the new features. So this is an approach that we use a lot in a lot of our clients. We know that we need to improve certain architecture styles or even upgrade certain technologies. And instead of stopping business as usual, we can take, okay, what are the main features coming next? So let's design the new features already using the new architectural style or the technology that we want to use.
Yeah, I mean, another example is related to change. So for example, you often get this problem when database is used as almost as an integration layer. So it becomes a place where data is readily available and other systems, departments, and even reporting tools start reaching into the actual database and start building features or reports off the back of that. So what happens is you've got a point of coupling across many teams. And this often then can mean that change is much slower. And so that's another area of focus. So in order to make change faster, you can start addressing that. You can start decoupling those dependencies at the database level as well.
Mm-hmm. And this is a particularly tricky one. I've come across this recently. And because you have almost no idea of the reports and other small programs and things that are running, excuse me, off this database. So it's extremely brittle. So the development team just can't make a decision to make these changes and even iteratively guide this database in towards the direction they want it to, because any change will break something that you didn't even know existed. It's a particularly tricky problem.
Mm-hmm. Mm-hmm. Yeah, another one that we see a lot is what we call code hotspots. This is not always easy to show the business value, but you can look at this in terms of how easy it is to parallelize work across teams. So let's say that in order to optimize your development process, like you have different development teams and you want, of course, if you have multiple development teams, you want to parallelize work. So why are we not able to do that sometimes? Why? So every time that if we analyze how the teams are cooperating, if it's like, do they have dependencies on each other? Are they changing the same files, the same areas of the code base? So analyzing the dynamics of how easy it is to parallelize work, how easy it is to create a backlog where the teams can be productive. is also another way to prioritize modernization efforts, because what we want to do is to make sure that you can prioritize work independently, and every team can take their stream of work and be able to get on with it. So then and map that those, we should have very few contact points and between the teams, and very well-defined contact points. But for that, the system, the structure of the application needs to enable that.
Mm-hmm. One way to identify what areas are making your job more difficult is to look at, the coupling points. So where when you try to make a change, what else is impacted that's not within your control, and those things slow you down, whether that is at the code level or at the organization level. And the other part is the cohesion points, is that, you want to make change here, but you also have to make a change somewhere else, which is the other side of it, right? So, for example, it often happens with, where you don't have good level of integration between, let's say, older systems or kind of supply chain type ERP type systems, and more kind of e-commerce type or front end systems. And you need a particular field or particular thing that isn't there. And actually getting that is a big job, because you have to go across different departments. But similarly, you might have, you might be making changes to something and you're providing a feed, or something doesn't become, is no longer viable. And how do you then coordinate that change? So that coordination is also a large sink of effort and time.
Yeah, and what we see also, most people say, oh, we have a lot of technical debt. And all the things that we described, they are different forms of technical debt that you incur over time as things are changing. But we need to be careful, like when you say, oh, our main drive of the software modernization effort is technical debt, because it's very generic. And we need to be careful with that definition, because whatever we do needs to have some business value. And just because SonarQube or all those static analysis tools, or any other dynamic tools like CodeScene and things like that, just because they are saying that there is an issue in an area doesn't mean that you need to prioritize that area, right? So we also need to say, are we changing this area in the near future? Mm-hmm. Or as Mash and Steve were saying, like, what are the real pain? Are they causing us pain right now? Or it's just like, yeah, because just the fact that we don't like a piece of code doesn't mean that we should spend a lot of effort fixing that if it's not in our way. Mm-hmm. As developers, of course, we want to do it, but we need to be careful with that one.
I think this is a very interesting point, isn't it? It's about these proxy indicators of technical debt. So we think our test coverage, or even coupling, or hotspots, or all of these, they are ultimately proxy indicators of technical debt. The real indicator of technical debt is about change. What's stopping you from making change happen in the simplest and quickest way possible?
Yeah, what are you trying to do that you're not able to do, or not able to do efficiently, right?
Yeah, exactly.
I was going to say about tech debt. The other thing is I know we're going to talk about modernization, but the other thing is, if you are taking on tech debt, just being very aware of it. We're working with a extremely fast-paced startup at the moment, and in order to launch, they took on tech debt, right? And they had manual process in the background. There were emails being sent and spreadsheets being maintained, but always with the software was always designed knowing that we want to replace that later. So there was always extensibility points, and there was always that was always held in mind, and it was it's perfectly fine for
a conscious decision.
Yeah,
a business decision.
It's perfectly fine to take on debt as a business of any kind, as long as it's planned debt.
Exactly. So there are also, like, once we understand that, what are the areas that we're trying to, or the kind of problems that we're trying to focus, that's when the techniques and architecture styles will come in as well, right? So in the previous episode, we talked about modularization. I think Mesh was talking about modularization before, and reducing the cognitive load, and being able to work in different parts without impacting each other and things like that. The modularization is extremely difficult to achieve. So because we can modularize systems, I think we also mentioned in the previous episode, at multiple levels, right? So we talked about can be at a high level enterprise architecture level, like which kind of systems do we have, what kind of high level features they will have, all the way down to classes, functions, namespaces, and stuff like that, right? So they are all different degrees of modularization. But for example, a lot of people, well, at least in a lot of our modernization work, we see a lot of monoliths out there. And we know that modularization is key. But actually defining those modules and defining at which level you're going to modularize, it's very, very complicated. So there are a few advice that we give. For example, in a monolith, there are many advantages of working on a monolith in terms of modularization because most of the features are there already. So you can look at your existing system, it's already a large system, and you can start clustering those features and those kinds of behavior, and that will give you an indication of what needs to be put together, let's say, right? Mm-hmm. But then there is a decision of, okay, once you understand functionally what should be together, what do you do physically, if that would be the term, to modularize? Do we just move those things to different namespaces or packages? Do we create like DLLs or jar files? Or do we create a full-blown microservices approach? Like, do we go all the way to physical systems exploring that? So the guidelines that we tend to use is, if you are not certain, keep the modularization at low level. If you are not quite clear about the boundaries of those modules, keep them together physically and make a soft module in terms of everything is just like in a different namespace or package. They can still access each other, because while you are doing that exercise, and then you try to, so you are first of all validating the amount of behavior that you're going to put in each module. And we're also trying to validate the interface, how those modules connect. Because you need, let's say, if you're working with classes like in OO or Java, C#, you still need to define which classes, how one module goes to the other. Are they going to call one class, multiple classes? So that exercise, you are defining the APIs of those modules. And we need some time for that to stabilize. Once you feel that it's really stable, then you can take the next step. Now I'm going to make a physical separation if it is necessary. Right?
Well, this is about how you draw those boundaries, isn't it, between modules? So the stronger the boundary that you draw, the more difficult it will become to change it later. And there's also a psychological thing as well. People are less inclined to change those boundaries. So if you draw the boundaries a bit weaker in the beginning when you know less, you have more of an idea or more of a let's say ease in changing those boundaries if you feel actually, now that we know a bit more, they should be a bit different.
So then there is the whole microservices, right? So there are also priorities, like in terms of going to a microservice. Because when you say microservice, I'm always a bit worried that you shift complexity, right? So the monolith has loads of advantages, because it's very easy to change as those boundaries change and as the system evolve. It's still the same code base, right? So doing a refactoring across boundaries in what we call a modular monolith is much easier. Your deployment environment is much easier because you have one system. As soon as you go to microservices, that shifts. The boundaries are much clearer now. You can really change in isolation as long as the APIs remain the same, but you shift complexity. So there is a price to be paid in going microservice, but you gain in scalability, you like in really separation of concerns. You can deploy things more often because you can deploy different services at different speeds. You don't need to deploy the entire app. You don't need to test the entire app. But it's not, oh, let's go microservices and everything will be beautiful.
I think one, if you do decide to go towards a microservices route, one thing to get right at the beginning is your CI/CD pipeline. So we often actually help our clients create a reference CI/CD pipeline that is effectively a template, right? So for a microservice, it has all those platform and pipeline related elements built in, and you can kick off a new service and start building the features. What that does is make it easier to, if you actually find that you made the wrong decision and that something should not be a microservice and should be in something else, you can move it in to something that already exists or create new ones. So, because often if that part is difficult, creating a new service is difficult, what will happen is people will, again, be more inclined to move things into existing services rather than create something different. So set up the infrastructure, the log aggregation, all these, observability part, everything else, set all these things up front, because they will get in the way and make people have people make more kind of tactical decisions, which are not necessarily related to what you're trying to achieve. They're just because they have these constraints on deploying new services.
Mm-hmm. And the that observability and traceability bit is key. You can't trace a request through like you can on a monolith, right? You can't just step into stuff. You can't and to do that up front is something to consider. Doing it afterwards, and I've been there, is horrendously difficult to go through all those microservices and make sure that you're passing these correlation IDs around and you have all this traceability in there. Doing that after the thing is built is that's a task no one wants.
Yeah. Another big advantage of having a monolith is that you can get that up and running on your local machine much quicker than a microservices based system, right? But you need to be able to do that, because if you don't have the capability to run your full system on your local machine and be able to play with it, you are creating, again, a constraint for people to adopt and evolve their system in the best way needed rather than what's already there.
Because it depends on how small and fine-grained you end up defining your services, because there is somewhere in between. You can take like a full functional area of your business, like a payments area, the catalog area. Those areas are complex. They have loads of functionalities, right? So you can put all of that functionality in a single service. It doesn't need to be a small service, can be a bigger service, but you can also, so they are in somewhere in between. You neither have a big monolith, but you nor have like hundreds and if not thousands of very, very tiny functions somewhere. So you might also calibrate the amount of behavior that you keep together, and there might behavior that you keep separate.
Yeah, almost like a core and then smaller services around it, isn't it? You may have a very well-structured monolith in the middle, and it just makes sense to keep it as a monolith. And then smaller services where it makes sense to deploy things separately. Sometimes the monolith can be deployed so easily that you don't need to have, you can have multiple deployments of the monolith on a daily basis. And, then you need to ask yourself, do you need to kind of extract that into multiple deployments as well?
And the number of developers working on that impacts as well, because if you have just one or two teams that can easily coordinate their work, it's okay for them to work on the same code base. But if you have hundreds of developers working in parallel, having exactly the same code base and the same deployable makes it much harder to coordinate all those changes and test them together and so on.
When we talk about microservices, generally we talk about cloud-based microservices, and we need to talk about the kind of transient faults that just happen on the cloud, right? So if you're running in a monolith and you're calling a method from another method in the same process, that method's there. With microservices architecture, you don't know. Right? Are you going to get so we need to start thinking about things like queues and retries, and what do we do with failed messages, and we don't there's a lot of complexity to be built in there, so it's a lot of extra things to think about, and how we deal with not just deal with the failures right now, but now all of a sudden we're in an asynchronous programming model, which is again is another layer of complexity on top.
Yeah, there is the whole idea of the service mesh is kind of coming out again, and this is actually again related to taking that complexity and putting it at a different level, because the retries, the queues, these are big problems, And if you are trying to solve them individually within every single call that you make, right, that's not going to happen. So the idea of service mesh, for example, is to provide this kind of different levels of availability, circuit breakers, all these kind of things, asynchronous behaviors at a more of a infrastructure level.
I think definitely the theme that's coming through as we spoke about last time, and I like how we're talking about the complexity, but it's facing into that complexity by breaking the problem down and kind of looking at each individual kind of strategy that needs to be applied within your own architecture and kind of personalizing it. So looking at how the architecture is currently set up and applying the right strategy for that, and then kind of looking at the complexities with each of those strategies and putting some practical kind of tools and techniques in place, like putting in the observability and the pipelines all up front so you're not where Steve was and having to retrospectively do it and feeling the pain with that. So I like how, it's breaking the problem down at each stage, and by tailoring, the answer to that problem and that complexity each time within your own architecture is really helpful advice.
Yeah, there are more also, because quite often when we talk about modernization, we tend also, well, most of the time we tend to look at the back end. We tend to look at the services, we tend to look at the where the business logic is. And this certainly has loads of challenges, but a lot of us, like, we end up shying away from things that are really difficult to solve. Front end, like take a big monolith with loads of different screens, or like decoupling that is extremely difficult. And then there is a database on the other side as well. Mm-hmm. So in one of our large modernization projects, our client has more than 1,000 screens and more than 2,000 tables in the database. So yes, we can modularize the core of your system as much as you want, but what about the front end and the data? So this is a very, very difficult problem. And also, like, what are the cases where you are modernizing your system when you are going to a new stack? Because, like, when you are still in the same stack, like you have a big Java monolith and we are just modernizing that, but you're still sticking with Java. It's just great. But, like, what if you're coming from PHP to Java? Or, I don't know, to C# to TypeScript or whatever, or Node.js, right? So this creates a completely different set of complexities. And then there is the enforcement, because, like, you don't go from one to the status quo to that new vision in a few days. It takes a long time. So while you are in that process, you need just to try to enforce that behavior. Because if you have a few hundreds of developers working in that thing, you need to rely, while the physical boundaries don't exist clearly, because that's another advantage of the different services, as we were, there is a physical boundary. There is a separate code base, a separate deploy. So you can enforce discipline already by the physical boundaries, but when you don't have the physical boundaries, everything is just in different packages and namespaces, you rely a lot in education. So you need to try to create those boundaries as soon as you can, to look very awkward for you to duplicate effort. Database is an example. You cannot, how do you avoid that? If you have 2,000 tables or whatever, how many tables you might have, like, how do you avoid people going straight to those tables without going through the module that you are creating? Because when you're modularizing, you modularize the whole thing, right? So all those screens, all that business logic, and all that data that the module owns, which means that coding somewhere else in the application cannot go straight to the database and bypass the APIs that you are creating in front of the module. So one way that we are trying to address those things is to migrate keep the same database instance, but create schemas. Create a different schema per module, because then it becomes a bit awkward. You cannot just, like, go and to the DBC unless that you really specify that you are going. So then you know that is wrong, right? So, okay, like, I'm in here and I'm gonna go to this bit in here that is a different schema So maybe there is an API, maybe I should go from the front of the module, but those things are you need to start putting in place, because otherwise you'll never break the data dependency.
Yeah, and the front end too. Remember, we're talking about modernization, so probably you've got some really, nasty looking ASP, JSP, PHP, whatever, where everything was just a big, it was commonly known as spaghetti, right? So it can be really, really difficult.
Yeah. I mean, speaking of ASP, JSPs, there is one common pattern that exists in these kind of apps is global state, right? So it's the HTTP session that is the problem, right? So each request sticks something in there, and a very different part of a very different feature may come and reach into that. So suddenly you have no idea what's being kept in this big bag of fun, So how do you, like principles, as you were talking about, like teaching and people good software design basics is, like global state is not a good idea. State in general is not a good idea, but global state is much, much worse. And so don't create more dependencies on that. Every time you reach into that thing, think about how you can remove it rather than add to it, that kind of.
Any other practical case studies or examples that you've seen over your time, over your projects that are helpful?
There are minor things, but I believe that we would need a much longer episode. So I think we can talk about different techniques and architectural styles for a very, very long time. We didn't touch many other things that people listening might think about. What about the Strangler fig? What about versioning APIs, right? So all of those different things that we can also, what about domain-driven design? And so there are many, many different things to talk about, but I think that this is a good flavor of all the different techniques that we can have in modernization projects.
It's an area that we all can feels quite big and quite scary initially, and the conversations that we've had over these episodes are those practical steps to breaking the problem down, yet still facing into the complexity. I think are really reassuring to know that you can face into something that can seem quite daunting initially. I feel like we've almost got another, I don't know, theme of episode. Maybe there's the things we've learned from all of our various projects over the times, which is what Sandro was talking about. There's so much we can talk about, and there's so many different lessons learned from the different projects. So
we will have maybe we'll have a spin-off.
Yeah. The good, the bad, and the ugly from all of our previous projects and lives. Yeah, that would be an interesting one. Perfect. Well, thank you for your time today. I really, really enjoyed that low-level, detailed discussion. So thank you for your time and thank you for sharing.
Thank you.